Hello and welcome to another lecture in Administration of Operating Systems course. Today we will start talking about bash scripting. The idea of scripting in general is to make automation easier. So you really want to make sure that you don't have to do all the tasks one by one, that if you are doing something often, you can make easily tell computer how you want to perform every time, potentially depending on various circumstances, and then based on this information, you should be able to automate common tasks. And the nice thing about command line interfaces that it's really easy to do different kinds of automation, mainly because you have all the commands that are naturally repeatable. You have well-defined results. Every time you execute the same command, you will get the same result. It's different than, for example, graphical user interface, where you click on various things and it's really hard for a computer to figure out more or less why have you clicked in this particular place and not in any other place. In shell, all the, for example, arguments to commands are provided explicitly, so you don't have as much context dependencies. The other benefit is how easy it is to combine things together. So you have already seen the capabilities of pipes and redirections, and although this functionality is available to you when you are doing scripting, you can just build on top of it something even more powerful. And the nice thing about scripting languages such as Bash is that there is a full spectrum of capabilities. So you can start with something very simple, for example, just repeating the same command multiple times. And as your program or script grows, you can add more complicated and more advanced features of the programming language. So those kinds of scripting languages are not great for writing very complicated programs, but if your problem slowly grows, if you start with something simple and then you keep adding features or keep solving other problems, you will be able to quickly start getting some benefits and then have the solution be extensible if it turns out that it needs to be more and more complicated. So we will be talking about bash scripting in the course, although almost all modern shells have built-in programming languages which are pretty powerful. There are different flavors of them, but in this particular course we will be talking about bash. Most of them differ with, for example, syntax, but the general idea of how they are designed and to what kind of tasks they are especially suited is similar across other shells as well. Now, it's important to remember that those kinds of scripting languages, they are not really designed with programming in mind. The main purpose of shell is always the interactive work. And this puts some constraints on what you can do from the scripting side, because basically almost every line has to work the same way, both in script and in command line when you are just typing it standalone. So you really want to make sure that the programming aspects of the scripting language don't interfere with the interactive use. And also, those languages are pretty much all evolved over a really long time. They are not new languages. So there are some problems which are caused by backward compatibility. So you really want to make sure that you don't break scripts that are currently working. So whenever you are adding features, you have to find out a way of adding features without breaking programs that are already there, which means that a lot of those features don't really feel all that well integrated into the language. So there will be some annoying features within the bash programming that partially at least come from this backward compatibility thing. And all those things together mean that those are not really general purpose languages. So if you have a real programming problem, Bash is most likely not the right solution for you. But for small projects, and especially for the administrative tasks, those are pretty good. And they are also pretty good glue languages. So if you want to combine multiple utilities, if you have a task which consists of some number of smaller tasks, and for those smaller tasks you have appropriate tools and just want to bring all those tools together within one framework, then Bash is probably a reasonably good language for you. So the simplest case of Bash scripting is basically just sequences of commands. So you have already seen the semicolon operator, which allows you to put multiple commands on the same line. Like in this case, there are 2 echoes that will be executed. But you can also do something like this just by putting those commands into a file. So you can create a file with those two lines, and then you can tell Bash to execute this file. And what Bash will do is it will read the file line by line and try to execute each of those lines. And it's really important to remember that basically all the scripting is done this way. So if you are not sure how to make a script, or if you are not sure why a particular script is not working as you intended it to work, you can almost all of the lines just try executing by hand in command line and see what kind of results you are getting. This is very helpful in trying to figure out what actually happens. And especially for more complicated commands, it can save you a lot of time if you first figure out how the command should look like, and only after that you put it in a script, particularly if the script is actually containing some kind of non-trivial logic about when the particular command should be executed and so on. So if you think about script files, there are a couple of things to consider. So first of all, those have to be regular text files, not Word documents, for example. Those need to be ASCII files with just the commands that you want to be executed. And for that reason, it's pretty important to have a good text editor. So Nano is not terrible for simple scripts, but if you ever try to make a bigger script, then you will probably be interested in finding a better editor for this. Features such as syntax highlighting or automatic indentation makes it much easier to actually write scripts without having to worry about all those small annoying details, because the editor will make sure that if you make a mistake in, for example, syntax or just spelling error, a lot of those will become immediately obvious due to, for example, different colors. In general, you put one command per line in script files. So you can think of a script file as just a listing of command after command that you want to execute. Now, if you have a very long command, you can break it into parts and then you can continue each line by using backslash. But especially for the kinds of scripts we will be doing during the course, it probably shouldn't be necessary. It's important to be aware of the hash character. So this is a character that denotes comments. So anything that starts with hash, all the text until end of line will be ignored by the bash. It will not be executed. So the idea is to add some information for users who read the file. So to explain what a particular piece of code is supposed to be doing. But then it's also pretty useful for temporarily removing parts of code. So if you write a script that doesn't work the way you want it to be working, you can comment out parts of the code to figure out which parts are working and which parts are not working. And this can be pretty useful in finding problems. And finally, in order to run a script, you need to have the read permission for the script file. You don't necessarily need the execute permission. And something to remember is that it's very rarely that programs actually work correctly the first time you try them. So most of the time it will turn out that you write a script and something is wrong with it. And finding the cause for problems can actually be difficult, especially because you have to consider that there are two major kinds of problems. So one is syntax problems, where the idea behind your program is correct, but you have just wrote it incorrectly. You have used a different command name, or you have misspelled the parameter, things like that. And the other class of problems are logic problems, where you didn't really explain to the computer properly what it is supposed to be doing. So your program is syntactically correct in a sense that it does exactly what the commands that you have given are supposed to be doing, but it doesn't really solve the problem that you have. You have either misunderstood how the commands work or how to combine them in order to solve the issue that you have. And it's very common that it's not clear which of those two problems you are facing if the program is not working. So it's really important to be paying attention to the error messages that computer is giving you. And sometimes they are pretty difficult to understand, but they often contain at least hints about what can be wrong. So trying to understand them and figuring out what could be the cause for those error messages is often worth the effort. And it can be also useful to run scripts in so-called debug mode. You use -x argument to do, so you bash -x and then script name. And what it will do is it will print each command before executing it. So this is the command that the bash will execute. This is the result of the command, or what the command prints. Here is the next command from the script. Here is the output of this command, and so on. And obviously for such simple scripts it doesn't seem particularly useful, but for more complicated scripts the debug mode can show you what's happening and why some things don't behave as you would expect them to be behaving. So if you want to execute a script, you have already seen that you can do bash and then script name. Now the issue with this is that you have to know that this is a bash script, and if you have just written it, then it's fine, but in general it's not something that the users should care about. You would really want the script to be executable just like any other utility. You shouldn't know if the script, if a particular utility is a bash script or if it was written in any other programming language like C or Java. And in fact, that's how it actually works. If you see, for example, the which utility which you have used before, it's by default in here, and then if you check what kind of file it is, it turns out that this actually is a shell script. But still, you can just call it normally as any other executable. So the way it works is the Unix system has to know what is the file type of any utility that you are trying to run. And what it does is it uses so-called magic number for figuring it out. So it examines the first few bytes of the file, and it's looking for some known value that will tell it what kind of file it is. And in particular for bash scripts, it uses something which is called shebang, and this is how it looks like. So the idea is that the hash and exclamation mark means it's an interpreted text file. So this is not a binary executable file, it's a text file which will be interpreted by some kind of scripting engine. And then whatever follows is actually the path to the interpreter. So instead of bin bash, you can put anything here, any program which is capable of executing this particular script. So for all different kinds of scripting languages, they will all have similar structure here, just different executables in this place. So you can have Perl, you can have Python, you can have Ruby in here, and Linux system will figure out that this is the utility that actually should be executed, and it should interpret this file line by line. In Windows, for example, this kind of decision is made based on the extension of the file. This is what tells you what kind of file it is. For example, if you want to execute a file, it has to have either exe or com extension. But in Unix systems, it works differently. You can name your files whatever you want, and it's actually the contents of the file that tells what should happen there. But this also means that script files are not really executed. So when you are starting a new process with the script, you don't really execute the script itself. You create a new bash process, and then this process will just read the file and do whatever the file says. So the script itself doesn't really need the execute permissions. You need to be able to execute bash, and then bash just needs to be able to read the contents of the file. Now, if you want to actually run the script without explicitly calling bash, but just by using script name, then the script still has to be in the path variable, or the directory in which the script is has to be in the path variable. Or you can of course provide the actual path. So it's pretty common to be using that kind of syntax, basically saying that I want to execute script which is in current directory. So there are overall three major ways of running bash scripts. One is you say bash and then name of the script, and of course this can be either relative or absolute path. That doesn't really matter. You can choose whichever one is easier for you. And the only requirement here is that script has to be readable. The other option is to use syntax like this. So this is the script name, but you provide explicitly the path information. So you can be relative or absolute path, but there has to be path, not just the name of the script, but also the path that tells it where it is. And as I said, a common example is saying that I really want to execute script from the current directory. Now we are not saying it necessarily is bash. So in this kind of syntax, the Linux operating system has to figure out which interpreter should execute this script. So you need the shebang line within the script. In this case, it doesn't have to be there. Since it will be executed by bash anyway, you don't need the shebang line. The script, of course, still has to be readable, and now it also has to be executable. In order to use this kind of syntax, even though you are not really executing the script, the file has to be executable in order for Linux to understand what you want it to do. And finally, you can just use the script name, and it has all the same requirements as previously. So it has to have the shebang line, it has to be readable and executable, but now it also has to be in the path environment variable. And in general, this is just a matter of security, that you don't really want to by default be executing programs from the current working directory. And again, this is a difference between Linux and Windows. In Windows, by default, you are checking current working directory for programs that you're trying to execute. But in Linux, the idea is that most programs are supposed to be somewhere in the path environment. And if you really want to execute something from current directory, you can always use this kind of syntax. Now, coming back to what you actually want to put inside scripts, one very important thing is variables. And we have talked about variables a little bit before. There are a couple of cases where you would actually want to use variables just in command line interactively, but in general, variables are most useful within scripts. So you already should remember how to set up a variable, how to get access to the variable, what's the difference between this and this kind of syntax, and so on. But if those examples are not entirely clear to you, this would be a good time to try those things on your own. Now this video especially, I would strongly suggest that you try typing a lot of those examples here and try to figure out why they behave in a particular way. So I will not really be showing you all the examples of how things work. I will be giving you a number of examples of things that are potentially interesting, and then it's up to you to figure out what they actually mean and why. As far as variables go, there are three different kinds of variables. So you can have environment variables, which are basically part of the system configuration, and they are accessible to all the programs. And some of those you have already seen, like path, user, pwd. Those are environments which define the configuration that you want to be using, and they are accessible to all the programs, or at least all the children of a given process. So if they come, for example, from your login shell, then all your programs will have it. If you modify the value of one of those variables, then those modifications will only be visible to programs, to processes that you start after the modification. And you can use the export command to mark any given variable to be passed to children processes. Any other variables are called local variables, or sometimes called also user variables, and those are typically defined within a given script, and they only survive, they are only visible within a single bash process. So if you are starting a new script, it creates a new process. If you define some variables in this script, those variables will be available in this particular process, so for as long as you are executing this script. But once the script finishes executing, the process will be killed and your variables will disappear. And finally, there are some built-in variables which have special meaning, which are provided by the shell, and they are typically read-only, so you cannot really modify them. You can just use them to get information from the shell. So here is an example of how it works. So you can define a variable and you will of course be able to get its value. But if you start a new bash process, then the variable is not available there. However, if you export it first, then it's available both in this process and also in all the children of the process. And it's also often going to be important to be able to modify a variable, because let's say if you want to add a directory to the path, one example would be to try something like this. But that's not really what you want, because if you try to do this, then it will suddenly happen that, for example, ls command disappears. And of course, the reason why you can't use it anymore is because it's not in this directory. So what you really wanted to do is you wanted to just add this to the current value of path, not replace the current value of path with this. So the way to do it is using this kind of syntax. So you assign to the path variable the current value of path plus whatever is following here. And it's important to know that this will work the way you expect it to work. So it's guaranteed that this value will be looked up first. You will calculate, or Bash will calculate the thing on the right, how should it be, and only then will it override the current value of the path. And in this particular case, you of course have a choice of putting it at the end or at the beginning of the path, and you can definitely think about what's the difference between those two cases. And if you do it like this, then ls will continue working fine, so that's much better. We have talked about quotes before, so the difference between double quotes and single quotes, the meaning of backslash, those should be all pretty familiar. But now when we are talking in more detail about variables, you can think about more complicated issues. So for example, if you define variable x as hello, this one will do what you want it to do. But let's say you have a variable which is hello and the space, and you still want to say hello Slavek with just one space. This will clearly not work, because this one will be looking for variable like this. Bash does not have any way of knowing that you actually mean variable called x and then followed by characters Slavek. This looks like a perfectly valid variable name, and obviously Bash will try to find the longest possible name that makes sense. So you can use this kind of syntax to tell Bash those brackets here don't really have any other meaning besides telling Bash that this is the variable name, and then everything else should be just a string. And you can also think about why is there a difference between those two commands and where does it come from. I have said that there are also some built-in variables, and of those the most important are so-called positional arguments. And the idea is that those arguments are created by the shell when the script gets executed, and they give you access to the command line arguments. So whenever you are calling a script and giving it some kind of arguments, for example, you have been using which command before, that one gets arguments. As an argument, it gets the name of the utility that you want to find. So somewhere inside the script, there has to be a way of figuring out what kinds of arguments or parameters the user wanted to pass to the script. And for this, you are using those positional arguments, at least that's one way of doing it. And arguments or variables $1 to $9 are the actual script arguments. There is also a variable called $0, which is the script name, which can be sometimes good to know. There is variable $hash, which is the number of arguments, so you just want to check how many arguments the user has provided. And then there is variable $star, which is the concatenation of all arguments. So it doesn't give you access to them one by one, it gives you all of them at the same time. So the idea is to control script behavior by calling it with different options or arguments, and this is how most utilities work, and yeah, which is an example that you have already seen. And then as a programmer, your goal is to figure out what's the easiest way for user to specify what they want using those kinds of positional arguments. So here is an example of how it works. Let's say we have a script like this. So it basically just prints a number of different things, and we call it in this particular way. So figure out why the output is like this, what each of those things mean, both in here, but also why there is a difference between this hello world and this hello world. And apparently there is. So for example, the script gets 3 arguments, and it's important that you understand why the number here is 3. We have talked about arithmetic expression before as well, and again, the full potential of them only becomes visible once you start doing scripts, because the main benefit of scripting is that you write your script once and then you can execute it multiple times with different parameters provided by the user, and then if some of those parameters are, for example, numbers, it may be useful to perform arithmetic operations on it. If you are doing commands on the command line, then there isn't that much benefit of doing simple arithmetics like this, because it's typically easier for human to do it in their head. It's much less typing to just type 2 instead of dollar parentheses parentheses 1 plus 1 parentheses parentheses. That's a lot of typing. But if one of those numbers, for example, comes from an argument that the user provides, and the other one comes as a result of one of the utilities that you have executed before, then this kind of arithmetic expressions become much more useful. And similarly, string operators and so on. So understanding those kind of things, how they work, why they work this way, is going to be useful for you in writing those kind of simple scripts. You definitely also need to still remember the redirections and pipes. Those are probably the backbone of bash scripting. This is the most important aspect of it, because as I said, bash is a pretty good glue language, so you really want to be combining existing utilities. There are a lot of things that you could do directly in bash, but most of the time, if there exists a utility for doing it, it's better to just call this utility and have it do the actual work instead of trying to do those kinds of operations in bash. So redirections and pipes are things that you will be using a lot in scripting. And the general approach is to split your task into as many small parts as possible. And the idea is for each of those small parts to be solvable using the commands that you know. So ls, grep, find, all those commands that you have been using up to now, you still can and should be using them in scripts, but now the idea is that you can combine them in pretty powerful ways. Command substitution is also something you have seen before, and the general idea is to capture output of a particular command for further processing. And you can do it either as a pipe, and then you will have this output be directly piped into input of another process, but sometimes you want to use it, for example, as an argument. And you have looked at the xargs command before, but if you want to do something even more complex, then you may want to capture this value, for example, in a variable, and then process this variable in different ways. So a simple example is in here. You can just get the current working directory into variable called directory using those quotes or using this kind of syntax. And you can do very simple things with it, like, for example, this kind of operation. But in practice, it's actually very useful for a number of things. So here is a script which is not entirely useless. So what happens is that you first capture the current date in a variable called today, and then you use this variable in multiple different places. Finally, it wouldn't really be automation if you had to type each command that you want to execute. So the idea is to use something more powerful, and one of the features that you can be using is loops. And today I will talk about the for loop. So for loop allows you to do a similar operation multiple times with different arguments. So the general structure of the for loop is like this. You start somewhere and then you define variable name that you will be using within this loop and what are the values that you are interested in. And the variable will take each of those values in turn and you will execute the so-called body of the loop. So when you start here, x will become 1 and then you will execute whatever operations are in here, and when you reach the end of the loop, the bash will look, so are there any values left here that we haven't used yet? And on the first iteration, there of course are. So it will go here, it will fetch the new value for x, so now x will become 2. It will do the same operation again, except now x has a different value. Previously it was 1, now it's 2. So if there is something here that depends on x, it will do a different thing. And it will continue checking, are there any more x's? So next time x will be 3. You will execute this again. X will become 4. You will execute this again. X will become 5. You will execute this again. And now there are no more values. So now we are done. We exit the loop and then we will be executing whatever commands come after the loop. So the idea is that it's pretty common that you want to execute the same or similar command multiple times. And one of the common examples is when you do have a predefined list of arguments. And the syntax for the for loop looks like this. So you have the keyword for, you have a variable name that you want to be using, and this can be name of any variable. There is the keyword in, and finally there is the list of values that you want this variable to be taking. And then there is the so-called body of the loop, which starts with the command do and ends with done. So there can be multiple commands in here, so you have to tell bash where it starts and where it ends. And in here that can be any kind of command, but you typically want to be using this variable in some way, because this is the thing that will be changing. If you are not using this variable, then on every iteration you will be doing exactly the same thing, and doing exactly the same thing is of course much less interesting than doing similar thing. There are other kinds of loop as well. So there is, for example, while loop, which will continue being executed until some condition becomes true or false. But this is something we will be talking about on the next lecture. For now, we are talking about the for loops. So here is an example of very simple one, something that could work. So this will obviously just print red, green, blue on different lines. Here is a slightly more useful one. So as you can see, you can use the file matching wildcards as well in here. And this one will of course expand into a list of files with HTML extensions, and they will be separated by spaces, so it will be a valid value list. And then X will become each file in this list, one after another. And what you will do is you will search each of those files for a title tag and so on. And this isn't terribly useful because again, you could just put this directly in here and it will work exactly the same way. But what this allows you to do is it gives you more flexibility. So if you want to do more complicated things, again, it's easier to combine different utilities in this particular way. And here is even more complicated script. In this particular case, you are using the command substitution here, so you can try to figure out what this command does, and then what will be the values of x's and what's going to happen here. Now this is a syntax which we haven't really talked about, so it would be a good idea for you to figure out what does it actually attempt to do. Here are some more complicated examples, or examples that highlight some of the issues and complications in Bash programming. So let's say you have two variables like those, and you want to display both of those colors in new lines. The first attempt could be something like this, and this will obviously not work quite the way you would like it to work. You could try something like this, which will also not entirely work. And then the question becomes, why is this the correct way of doing it? So try to figure out what do those quotations in here mean and how are they interpreted by the shell. And you can also definitely combine the for loop with the arguments, for example, the positional arguments about which we have been talking before. So here we have our variable called arg, and here we have a list of all the arguments that have been passed to this script. Now you may also notice that in here we are using a slightly different syntax. So instead of putting the do on its own line in here, we are putting a semicolon here and do on the same line. And well, I'm doing it obviously because I don't have space for all four of those scripts if I keep wasting valuable space for putting do on their own lines. And again, the question is for you to figure out what are the differences between those four different versions, which one of them is the best, and what do you really want to be doing in this particular way. Similarly with command substitutions, so here is a very simple example of a sequence of commands which use command substitutions, and here is an example of command substitutions used within a loop. Here is another example of command substitution used within the loop, and this one is potentially more interesting. Now you can try to figure out what seq does, and you can also try to think how this can be combined with the $hash positional parameter, which was mentioned on the previous slide. Because if you remember, out of those four scripts previously, one of them was using $hash, and it was definitely not working the way it should be working. But you can use this kind of command to make it work the way you would like it to work. And by now I think you should know a lot about file name matching, so those things shouldn't be particularly surprising to you. Although it's important to remember that you can use this in a lot of contexts within the script. So you can, for example, just assign a list of files to a variable. And you can also combine different variables in different ways. So if you have a directory specified by the user, you can find all the text files within this directory by using a syntax like this. And you have already seen the use of for loop together with file name matching. So it's important to remember that this functionality, it's very useful in practice, especially for administrative tasks, because we are working a lot with files there. But there is also something to remember, especially if we want to be using those characters as parameters to your scripts, because you have to understand at what stage they will be expanded, because the shell will take star and replace it with the list of all the files in current directory, but depending on when exactly will that happen, you will be getting different results. So you have to figure out if, where, and how many different kinds of quotations to use in order to get the results you are looking for. Here is an example to illustrate this. There are two scripts which are pretty similar, and here I have a couple of ideas about how those scripts can be called, and then it's for you to figure out what would be the results here, and also depending on whether, for example, file called abcd exists in etc or exists in current working directory, there should be at least passwd file within the etc. But what happens if there is some file which starts with pass in the current directory? What happens if there isn't? And so on. So figuring out differences between those invocations and those scripts is going to be useful in making sure that you understand how those things interact. And one more example. In here you can see that there are two levels that user is specifying. And again, an example of what happens if you are using those wildcard characters. So you get different results depending on whether a particular file exists or not in your current directory, and you also can get kind of misleading results because this kind of file doesn't exist in etc, even though it would seem like it does. So again, the question for you is to figure out why you are getting this particular result. And that's it for today. I will see you on the lecture.